Assalamualaikum warahmatullahi taala wabarakatuh. Today we are going to present our project for hydraulic laboratory ECW 437 entitled hydraulic jump. We are from group 2 and the participants for this group is Siti Kursia, Amir Nizam Adli, myself, Muhammad Mustaqim, Fakrul Syahmi and Intan Najihah. Okay, now I'm going to start with the introduction. A hydraulic jump is a phenomenon in the science of hydraulics which is frequently observed in open channel flows such as rivers and spillways. In general, we can say that a hydraulic jump can occur when the flow changes from supercritical to subcritical flow, and it also depending on the initial speed of the fluid. Let's say if the initial speed of the fluid is below the critical speed, then no jump is possible. And for initial flow speeds which are not significantly above the critical speed, the transition appears as an undulating wave. And for this experiment, we use tailgate and we change the height of the sluice gate in order to observe and produce the hydraulic jump. And we measure the height or depth of the flow before and after the hydraulic jump. The objective for our project is to visualize the phenomena of hydraulic jump in a sluice gate, to compare the upstream and downstream depth of flows from experimental data to theoretical data, and to determine the energy losses and power losses through hydraulic jump, and to determine the equation for the length of the hydraulic jump.
Okay, my name is Intan Najihah binti Abdul Naim. So I will explain about learning outcome from our experiment hydraulic jump. Okay, first is identify and compare the upstream and downstream depth of the respectively for a hydraulic jump. Next is compute the energy dissipated in the jump and power loss at the hydraulic jump section based on the specific energy consideration. Okay, so next I will explain about theoretical background, but this is the full explanation of theoretical background, but I will explain it in very short and simple explanation about our experiment. Okay, hydraulic jump happen when supercritical flow change to a subcritical flow. The violent motion of water and elevation of water surface increases suddenly, then the strength of the jumps depend on the Froude number of the flow entering the jump. Okay, next slide is about all the formula that we use to calculate the result from the experiment, like Froude number, specific energy, and power loss.
For the problem statement, firstly, it is to study the characteristic of the hydraulic jump in open channel flow, to measure the position, height and width of jump, analyze energy dissipation and flow patterns before and after the jump, and to determine the effect of flow rate, channel slope and channel width on jump characteristic.
For this laboratory activities, we will be using a few apparatus. For the first one is sluice gate, the second one is tailgate, third one is vernier caliper, ruler, and upper flow channel.
Firstly, to start this experiment, we must measure the width of the channel by using the vernier caliper. Okay, firstly to start the hydraulic jump, we must set up the gate. We put it here.
Next, we turn on the valve to let the water flow.
Next, we put this for tailgate.
Okay, firstly, we measure the opening of the sluice gate. Then, we measure the Y1, which is the height of water before the jump. And lastly, we measure the Y2, which is the height of water after the jump.
Okay, then close the stopper, measure the flow rate and
When the water reaches to 0, we start to calculate time until it reaches 10.
Assalamualaikum warahmatullahi wabarakatuh. My name is Dr. Syami and I'm going to talk about the result for data and calculation. So firstly, we can get the width of the tank, which is 7.78 centimeter. Then we can get the discharge of the water by using the volume and time that we observe. And we can get Y, which is the opening of the sluice gate, Y1, which is the height of the water before the jump, and Y2 is the height of the water after the jump. After we get that, we can get the velocity and the Froude number of the water. Okay, so after that, we find the energy by using the equation Y plus V power of 2 over 2G. After we get the energy, we can find the delta E by subtracting E1 minus E2. After that, we can find the power loss by using the equation rho G times Q times delta E. Okay, that's all from me. Thank you.
Assalamualaikum, my name is Siti Kursia and I will talk about discussion. So this experiment allows us to visualize the phenomena of the hydraulic jump in the sluice gate and also to compare the upstream and downstream depth of flow from the experimental data to theoretical data. In these laboratory activities, we decided to collect 3 different data from the experiment. From the data we gain, we can also determine the energy losses and power losses through hydraulic jump by calculating it. Based on the result and calculation, we can conclude that there are 3 different values for energy losses and power losses because of the different height of sluice gate. This is one of the main factors of the differences between value of energy losses and power losses. On the other hand, the value also may be different between theoretically and experimental because of human mistake on taking data by reading the height of the water before and after the hydraulic jump and height of sluice gate opening. So that's all from me. Thank you.
Assalamualaikum. My name is Muhammad Mustaqim. So now I want to give the conclusion about our project. The hydraulic jump is a phenomenon that occurs when a liquid flow, such as water, transition from supercritical to subcritical flow. It is characterized by a sudden increase in the fluid's depth and a decrease in its velocity. The jump is accompanied by an increase in energy loss and turbulence, which can have the negative effect on downstream and equipment. Understanding the characteristic and behavior of hydraulic jump is important in the design and operation of hydraulic system, such as canals, spillways, and hydroelectric power plants. Engineers can use various methods to control and mitigate the effect of hydraulic jumps, such as using energy dissipators or adjusting the flow rates. That's all from me. Thank you.